This month I started an exciting new project, and like all developers I wanted the latest shiny tools, FastHTML for UI, and the gold standard AsyncPG for lightning fast database calls. Little did I know this was going to cause me some real headaches, requiring multiple modules to be heavily rewritten. To see how we got here, and how you can avoid falling into the same trap, let's rewind the hands of time to the 2nd of January. New year, new project. I had full control over what I was producing, and full agency over the design. I started the project like I start any other, by laying out the architecture and starting to rapidly prototype the components. This way I can get to a stage very quickly where I have a working skeleton I can start to iterate fast on. Things were going well. I had a minimal UI integrated with Google sign-in, I had a Google API spun up that let me pull the data I needed, I had my DB source control planned out, and I had built a no ORM high security database abstraction that I was proud of. Little did I know I'd made a fundamental error that I was going to regret. Yesterday I started cobbling it all together and it worked beautifully. So it was time to start working on the important basics. Top of my list was the security model. You have to get this right before you start building anything serious. Till now I'd been storing my Google credentials and claims in an encrypted cookie on the client, and I had a user management class for dealing with the data retrieval and decryption. This isn't best practice and it was time to remedy this. My project will have two user-facing components, a lightweight UI and a set of MCP services where the magic happens. The way these work with security is slightly different. To make sure I could reuse my user class handling for both, I set about building a back-end adapter that I could plug in to switch how things work on the data plane. And I started writing the database storage model to migrate the user management to where it would live from now on. I was done. Time for testing. This is where I discovered my schoolboy error. Async coding is not something I do very often. Give me multiprocess demons any day of the week. But most of the stack was async, and this was the key problem. Whilst moving quickly, I'd forgotten a rather fundamental issue. Async code is really a one-way street, and I'd created a messy sandwich, and no one wants one of those. The async code for the database and UI was working perfectly, because this is the tech these use and I had to pay attention. But the entire middle piece, user management, the adapter, the YouTube API, I had written with traditional synchronous code. For those of you fluent with async coding practices, you're probably laughing at me right now. And go ahead, I deserve it. I now had a rather annoying problem. My async code could call my synchronous code fine. Well, kind of, we'll get to that in a minute. But my synchronous code couldn't call back to the async database layer. At this point, I did what any efficient developer would do and started looking for a workaround. Never fear, Stack Overflow had a solution. AsyncIO.run was the answer to all my problems. But my sigh of relief was short-lived. Turns out that AsyncIO.run creates a new event loop. And I was already running in one, and Python doesn't like that. It slapped my wrists in the only way it knew how, a runtime error. AsyncIO.run cannot be called from a running event loop. So that wasn't going to be the silver bullet I expected. So I fell back to something that occasionally helps. Claude. It told me that AsyncIO was hacky, and after arguing with it like a colleague, we came to the uncomfortable truth. I was going to have to rewrite the user layer. If my challenges ended there, it wouldn't have been too bad. But then I engaged my developer brain looking for other things that would bite me in the arse. It didn't take long to find the next big issue. It turns out that a constructor in Python isn't allowed to be async, and the init of my user class indirectly called the database. So I had to create this monstrosity of an async pattern that the Python community has agreed is ugly, but the lesser evil of all the other possible solutions. This lovely piece of code meant I had to refactor a ton of calls to user to be more ugly. I kicked it off, ran it, fixed the last few runtime issues, and in no time my system was working again. That, it turns out though, was the easy bit. I had started to look at the YouTube API code. I knew this was going to be problematic, but it's only a problem once I prove it. When a user first registers with the system, it needs to pull in a full picture of their YouTube channel, so they can start to use the tool straight away. I decided to point the API at my gaming channel. This has over 10 times the number of videos of the one I was currently testing with, and as I suspected, it took a while, somewhere between 10 and 20 seconds. What was odd, I expected AsyncIO to lock my second browser, but it pulled the channel fine even while the long op was in process. This shouldn't be happening. You see, AsyncIO runs in a single thread, so if something takes a long time and is blocking, it blocks the whole event loop and everything grinds to a halt. Turns out that FastHTML tries to come to your aid running any endpoint that is not async in its own thread. This was why it was all still working. This would be fine if my tool only had to service a few users, but I had my sights on something a little more ambitious. I had to fix this because these threads would soon swamp a production web app. This is where the trouble started. Rewriting the YouTube API was going to take at most a day, or so I thought. I'm just glad I was nowhere near finished. So I started looking at what it would take. You would think that the official API client library from a company the size of Google would support async calls. It doesn't, and there's no plan to support it. This was no longer a fix, it was a rewrite from the ground up. My next choice to make was whether I was going to write my own wrapper around the YouTube API that supported async. I really don't like reinventing the wheel if there's something out there, so I started looking for community objects. And I came across AIO Google that looks promising. But that's a problem for tomorrow and maybe the rest of the week. I am still adamant that FastHTML and AsyncPG are the right long-term choices for my use case, but those choices have set me back. And whilst it's frustrating, it's not a problem. Every single architectural choice we make will have a trade-off. Weighing the relative costs of each choice, proving, failing fast, picking ourselves up, dusting ourselves off and trying again really is the only way that I've found over my almost 30 years tenure in enterprise architecture that we ensure we grow as developers, designers and system architects. It's better and cheaper to find these problems early before you hit them in production and affect potential customers. Remember this, failure is only failure if we don't learn from our mistakes. And in tech where things move fast, we're going to make a lot of them. Let me know if this video resonated with you in the comments. If you think I've made the right choice or have a better solution, would love to hear them. And before we fade to black, my final thought for this week is, they'll forget it was late long before they forgot it was rubbish.